Okay, so this is problem number 34 from the test 3 study guide. It says that given the function f of x is equal to x squared minus 2x minus 15 over x squared minus 25, to find the following, and then if none exists, we'll state none. Alright, so first things first, I'm going to go ahead and factor this whole thing. Alright, so our numerator, just like our last two problems, so we need two numbers that multiply to give us negative 15, add to give us negative 2, and we know that that is x minus 5 and x plus 3, because our negative 5 times 3, negative 15, negative 5 plus 3 gives us negative 2. And then for our denominator, we have a difference of squares, so we have x squared minus 25, so then we're going to have x minus 5 and x plus 5. Okay, so first things first, we can write out our domain, because we have our difference of squares that we factored out here, so we know that x minus 5 set equal to 0, so that'll give us x equals 5, and then x plus 5, so that equal to 0, we'll also have x equal to negative 5, which both come from here. Alright, so for our domain, we'll start at negative infinity, and go up to negative 5, and then our union, so then we'll start back up at negative 5 to 5, then another union, and then we have 5 to infinity. Alright, and then for our vertical asymptotes, I'm actually going to go ahead and start with our wholes first, because we see here that we have an x minus 5 in the top and an x minus 5 in the denominator, so those are actually going to cancel, which means that we have a whole at x is equal to 5, because these two canceled, and you use what was set equal to when you set x minus 5 equal to 0, which gives us x is equal to 5. So there's not going to be a vertical asymptote at x equal to 5. We have a whole because they canceled in the numerator and the denominator. Now we can go back up and do our vertical asymptote, because we know that we no longer have our x minus 5, but in our denominator we have our x plus 5, which when we set that equal to 0, gave us x is equal to negative 5. So that's our vertical asymptote. And then our whole is that x is equal to 5. Alright, so the next thing we need to do is our horizontal asymptotes. So for that, we need to look at our highest power of x in both the numerator and denominator. So in the numerator, our highest power of x is 2. And then in our denominator, it's also 2. So because they're equal exponents, we know that we're going to look at the leading coefficients, which happen to be 1 and 1. So 1 over 1 is just 1. So we have a horizontal asymptote at y is equal to 1. And then for our x-intercepts, well, we know that what we're left with after we've factored out, so our f of x is now equal to x plus 3 over x plus 5, which is going to make finding our x and y-intercepts way easier. Alright, so for our x-intercept, that's when we set our y is equal to 0, so then we have 0 is equal to x plus 3 over x plus 5. So we're going to multiply by x plus 5 on both sides. So that cancels over here. And then if we multiply by x plus 5 on this side, well, anything times 0 is just 0. So then we're left with 0 is equal to x plus 3. It's just 0 is equal to x plus 3. And then when we solve for x, we're going to subtract 3. So when we have x is equal to negative 3. So for our x-intercept, we have negative 3, 0. And for our y-intercept, so we're going to set all of our x's equal to 0. So we have y is equal to, and we're using our x plus 3 over x plus 5. So 0 plus 3 over 0 plus 5. So that just gives us y is equal to 3/5. So our y-intercept is at 0, 3/5.